Hi everyone, we're going to look at this question. There's a small correction here. There should be each recorded volume. Now, if you look at this question, it tells you that you have magnesium ribbon added to hydrochloric acid, and this is the initial concentration of hydrochloric acid. This is the volume of hydrochloric acid used, and the volume of hydrogen gas produced during this reaction is recorded every 10 seconds, and this volume is in centimeter cube. Now, the first thing that we're going to do, we're going to write an equation, HCl plus magnesium, giving magnesium chloride and hydrogen gas, and then you balance the equation. That's the first thing we're going to do. Now, assuming that the reaction was carried out at SATP and the solution volume did not change, so the solution volume stayed 0.1 dm cube, you need to calculate the corresponding concentration of HCl. Now, here you're given the volume of hydrogen gas. Now, from the volume of hydrogen gas, you can try to find the number of moles of hydrogen gas. And if you remember, number of moles of any gas, number of moles of gas will be volume of gas divided by molar volume. Okay, and this is at SATP. So here, molar volume is 24 dm cube. If ever you're in the exams, you don't know what is molar volume as at SATP, use your equation. PV is equal to nRT. Temperature is given, pressure is given, molar volume you have to find, number of moles will be 1, and R you know. So apply the equation, get the molar volume. You can also do that. You will get your marks. Now, you find the number of moles of gas. Now, if you know the number of moles of gas, you can use mole ratio. So mole ratio, number of moles of gas to HCl, this is, so H2 is to HCl, this is 1 is to 2. Then the number of moles of HCl is going to be twice this. So number of mole of HCl, this is going to be 2 times number of moles of gas. Now, from the number of moles of HCl, you can get concentration of HCl. Concentration is number of moles divided by volume. So it will be number of moles of HCl divided by the volume of the solution, which is 0.1 dm cube. As you're doing this calculation, the only thing you'll have to be very careful is the unit here. This is in centimeter cube, and here molar volume, we got it in dm cube. So you'll have to convert all of this to dm cube. And then from the concentration, you will plot a graph. So the way to do it is you have a table, copy this table here. So the way to proceed is to have a table where you have the time and you have the volume of hydrogen gas, and I already converted to dm cube. And from this, I'm going to have different columns until I reach the concentration. Now, initial concentration of HCl at time 0 will be the initial concentration given here. This is concentration of HCl. Initial at time 0. So this is going to be here. Now let me find number of moles of hydrogen. Then I'm going to find number of moles of HCl, which is going to be twice as this. So I'm going to find this times 2, which is going to be equal to number of moles of HCl. Then from number of moles of HCl, I'm going to get concentration of HCl that is being used, because this is volume of hydrogen produced. For this hydrogen to be produced, HCl has been used. So whatever concentration of HCl I get here, I will get concentration of HCl used during the reaction. And then I'm going to find concentration of HCl remaining. What remains? So when it says concentration of hydrochloric acid, it means concentration of hydrochloric acid that remains over here. So this will be left, HCl left. So I completed the first row, and as you can see, the number of moles of HCl left will be the initial amount of HCl minus the number of moles of HCl used. So you can verify your answer, and as you can see here, you'll have to plot time against concentration of HCl here using graph paper. So your graph looks a bit like this. Check your answers, your units, and your plotting, and include a smooth curve that goes through all the points. Mine is not going through this one. Make sure yours goes through all the points. And then you will need to find initial rate of reaction. So initial rate will be the rate at this point over here. So you will have to draw a tangent here. Draw the tangent, try to make it a long line so that you have a big triangle, and then from the tangent you find the gradient. The gradient is going to be the rate of the reaction. And the other one is rate at 55 seconds. So then you will draw another tangent at 55 seconds, draw another tangent over here, and then you will find the gradient of this line. So these are the 2 points that I've selected on the tangent, so 1 point, 2 point, and for this tangent, this is the 2 points that I selected, and you can find the gradient using these 2 points and these 2 points. And from this you get the rate at these 2 points. You will now do the MCQs in the homework section, MCQs number 1 to 5, and the structured question number 2 only.